You and I go hard at each other like we're going to war. You and I go rough, we keep throwing things and slamming the doors. You and I get so damn dysfunctional, we start keeping score. You and I get sick.
The other studies which is quite typical is what is called hazard and probability studies. So this is similar to hazard that there are guidewords for deviation, and then you, in this case, for example, like deviation is no flow. So in each study notes, you look at what can be the cause of creating this no flow, and then you identify the consequence and what are the safeguards, and then you perform risk ranking, and then if it's not safe, you has further recommendations. When we come to so all safety studies we do quite a lot will generate a lot of recommendations, and these recommendations will go into like a safety tracking risk register. So in that one we have to decide which recommendation we will implement and which one we may not fully implement, or we gonna if we are not implementing, how are we telling clients and why do we think we do not need to implement it? So in this area, the how we treat the risk is the point. So in the next slide, there will be an example of that. And usually risks are allowed when we justify that the time and the cost of further risk reduction is not proportionate to the chance of reducing the risk. But usually this one is like quite an intensive studies and justification that we need to talk to clients. When we look at a law, usually the baseline that we talk to clients will be on whether have we complied to all the code and standards requirements in a contract. So at least if we are complying, then the baseline you had a good baseline that you do what is the industrial normally do, so you comply to them. And then if there are some additional lessons learned from industrial incident, but maybe if the code is not fastly updated enough, you may justify, you may know that okay, there are some additional lessons learned beyond the code. Are you willing to implement? Usually, if it does not create high impact on the project, that cause like project delays, we look at them and we try to implement them to a certain extent to make sure that the facility is safe enough for clients. Or sometimes when it is very difficult to decide, we have to do like a cost benefit analysis. So, an example. From the blast that's shown previously, in one of the projects, I received a question from the project team. Can we, since your blast contour show that the blast is not as high, could we put the control room closer to process area, because we want to save cable length, because the cable length is also cost. So I received these questions from them. So I have to do an analysis to see if we move into different locations, what are the additional benefits. Of course, it's cost reduction for them, but what does it jeopardize the risk on safety side. So I have to look at, for example, like if I relocate to them, what are the chances that it will be in a gas cloud when there is a release, what is the frequency, if it's a blast, if there is a blast, what is the chance of it being right there? And also another one which is quite important, but many times it was a bit looked out, is that normally when there is a fire, you will receive like a heat radiation to quite a distance away. So sometimes we say, oh yeah, it's okay. The building is designed for the blast. The building is designed for the heat load. It can receive or withstand certain heat duration and load for like 2 hours, something like that. But can people inside run away from the building? This is like usually it's a question, and then that's why when we do this kind of evaluation, we have to be very careful, especially for this type of building where they will normally put people inside, because we have different definitions, like a normally manned building and not normally manned. So for not normally manned, usually it's a bit closer to process area, because we foresee that as a lower risk to expose personnel. But normally manned, you know that it's always the operator in control room to monitor and control the process. How many of them, and yeah, so this is usually the decision. And then once we do this kind of comparison, then we talk to normally to project management and say that your benefit of reducing cable cost is this. And if we have to relocate the building, what are the design impacts and what are the risk effects? And then we together as a team make a decision whether we gonna move or not. And also this has to be agreed with clients. So along with this is like an iterative process. So along the way, all the safety recommendations which come from different studies in different progress of the project has to be documented somewhere. And we have like here we have like a system database for register, but in some projects they prefer to use Excel, so it's kind of like freedom of choice and agreement with clients. Then we collect all the recommendations from which studies and what was the cost of those recommendations, and then we have to decide what is the response. Are we gonna implementing that? Sometimes we think it's nice to do, sometimes it has to be done. So we have to respond to that, and we send that back to client and say, this recommendation, we are doing this because of that. And then a client has to approve whether they agree with our justification or not. So once they agree, then we implement them into the design. And this process will be tracking until that is implemented and everyone sign off individual action sheets. So it's a very long project. So long process, meaning that from day one of the project when we start having recommendation until when the project commissioning and finish, we are tracking this along these 4 years, and yeah, and we need to make sure that all of them are closed and agree with clients. Yeah. So this before going into examples, just to give you like a feeling of how normally how engineering design project is progress in oil and gas. So basically, in the first step, we have process definition, we have doing like a mass balance calculation and what are the equipment lists. So this is like all the basis of design at the beginning. Then, as I explained, is doing the engineering design package, where you will have like you have to select material for equipment. We have to do some light sizing. And then we have like an equipment layout and plot plan. And then in the next phase, we will do more detailed studies that generate document which is called approved for design or AF. Yeah. And then further detailed development is progressing and you generate another set of documents which is ready for construction. So in that case it's approved for construction and then it's construction and commissioning. Yeah. So from safety point of view, we during the process definition when other teams are busy with all these deliverables, we usually define our philosophy, what is the kind of like a principle of safety for this project. So we define the philosophies and type of safety system we want to implement in this project. In the next phase, when they do basic engineering, we define a second tier document which is a specification. So in this case, it will be quite like a detailed design requirements of documents, and we conduct most of the screening through the phase the step 2. So we conduct like acid and edit during this phase because those workshops we have to do it as early as possible so that when we know there are some design issues, we can incorporate our requirements into other disciplines so that the design will take this into account. Then we once the design is mature enough, we take the design information of this from other disciplines and send it to the consultant to do all the fine and risk exposure studies. And then when other disciplines finish with the process design, we do the detailed workshop on the hazard and opportunity studies and the seal and NOPA to identify the safety integrity requirement. And then during the as project progress along, there will be some design change. So we have to rehash some of the scope changes and also reseal and NOPA. So all of the study phase here will go into the recommendation and the tracking system. So when we finish designing, when it's a manufacture and installation and before commissioning, there will be an audit of pre-startup audit to check if all the safety elements are in place already and ready for commissioning and startup. And usually an input, one of the inputs during the startup is the alarm report or alarm demonstration, but we have to take the alarm decision since the time when we know the recommendation from this phase and this study. So we have to work with it along the way because if you're gonna write an alarm report towards the end without properly done since the beginning, you will find that you miss some design elements to bring the risk down. And then it will be very difficult to convince the client that this design is already at alarm level because of that. So actually the monitoring process of recommendations come from different studies is very important in the project. Yeah. And it actually has become sometimes project risk. Yeah. So now I'm going to go into the example of how this framework has an impact on risk management. So there was one project which is in the front-end design of the stage, and we bring the noise requirement to a noise specialist, and then the noise specialist look at the numbers and say, oh, by the way, this requirement is very stringent. So I think we have to make sure that the noise mapping studies is taking place quite early so that we know what are the impacts. then at least okay you have like one trigger well since the context already that you you know that this may be an issue. So indeed, after we finish the noise mapping studies, we see that the noise contour for this project does not meet the legal requirements of client because client has a very strict noise level allowable at different times. So in this country, they define it in during different 8 hours, like from in the morning to lunch, this is one level that is allowed, and then in the evening is another level, and then at night time is another level, and each level is like it's a stringent requirement because they say that for residential area you need to have a good health, right? So in that sense, that's why they impose a very stringent requirements, and we could not meet that numbers for night time because the level was lower, like 45 decibels, I think. So in this case, what does that mean? In order for us to meet the noise requirement, we may need to put an equipment like compressor in a building, and this is like a cost impact. Luckily that in this case, we do it in the field stage. Yeah? So in the field stage, you identify all the design requirements. So you can tell client that, okay, this is potential issue, and hence we have to design like a compressor in a building for you, and it may require additional noise abatement, like a noise hood and enclosure, which will make your compressor become more expensive. But it has to be done because the noise level that we identify does not meet the legal requirement. So in the front end stage, if you identify this, then it's only design, it's just in paper, so you can incorporate them in, you can put them in cost estimation for the client because you know that this will be required. But if you did not know, or if you come to me for a project because you did not know the fee, but you take the fee package and you get an engineering design phase, and this issue was not flagged by previous engineering contractor, and you find out, it may mean that the money that you estimate for the project is not gonna cover this part, and it means you're gonna use your own money to make sure it's meet requirement. So knowing the same risk at different project rates make a significant impact on project management like cost and schedule. Yeah. In this case, we because we know it upfront, so we relocate equipment to because previously those noisy equipment are locating at the edge of the plant, so it's kind of at the edge to go out. Although the residential area that we had a compliance issue is like, I think it was like 500 meters or 1 kilometer away, which is quite far. But the noise level is very restricted. So in this case, I have to go and ask my project manager and say, could we relocate those equipment, noisy equipment right in the middle? Luckily, I could, and it did not really impact much of other disciplines because at that time there are still, the design is still not freezing, so you still have more chance to change things. Yeah. So then it was relocating, and then the noise abatement was factored in cost estimation for the next phase because for this project we were also bidding for this phase, so at least we have our money for that, and we have an explanation to why we have to reserve such a money. Yeah. The second case is we have like a pressurized vessel. Sorry, I do not have the words. we have like a pressurized vessel, and we have to make a design decision whether this vessel will be like a normal above ground installation, or are we gonna put it underground and bury them like it's called mounting. So in this case, we see that in industry, if you read the codes, you can do both. And then if you do above ground, you have to design like this. If you do it mounting, you have to take this into account. So the code usually tell you two ways of doing things. It will not tell you choose above ground or underground, but they say if you choose above ground it's like this, and underground is like this. So usually that's the way the code is. And normally it's either client or engineering design contractors who justify which system are you choosing. So in this case, at the beginning, since the beginning, we choose it to be underground, mounting, because of safety risk, because the inventory of this tank is very high, and it is quite a dangerous tank because of its inventory and it is LPG. So if an LPG from that huge inventory, it will continue leaking until it's finished. So we know that's the safety risk and consequence impact of the leak could be high. So we try to mitigate it as much as possible. So when we perform the HACCP at the beginning of the project, we already say that this unit will be mounted as a safeguard because it's our design intention to put it underground. But then later on, construction team came to the project and said that we had a lesson learned from previous project that if we construct it by having a mounting unit, it will have more construction cost and it would delay the project because from the previous experience it's quite difficult to make sure that the mounting process to make sure all the soils are even and compact, and all this is very detailed actions that require and is required a skilled contractor. And at this phase, of course, we are in feed and we don't know who's gonna be our contractors, what are their skills, and it's very long way ahead. So construction team asks projects, and most people actually challenge this requirement, whether are we gonna put it above ground or underground? Why does it have to be underground? So just for the basics before we go to the next phase. So in HACCP, we say it's gonna be underground. From the QRA, it's already demonstrating that the risk from this unit is low because it's under that mounting configuration. So at that point, we say we don't need to treat the risk for this unit any further because we do everything we could and we think it is a good design. But there were internal requests like this. So what happens is that we have to come back to re-evaluate the impact and then do the cost-benefit analysis to compare between options of underground and above ground. So in this case, one of the main concerns is that clients give us quite a small plot area. So by the code, if you put the tank above ground, the safety distance required is significant because it has to be 60 meters at least to the fence because of the inventory inside the quantities. But if we put it mounted, the general practice allows it to be 22. So at least I'm saving 40 meters. And in this case, it was significant because the way we put the overall layout, every meter counts. So yeah, it was quite a difficult plot arrangement. So one of the explanation is the safety distance. And then the second part is that if we put the bullet above ground, when it is leaking, you need to drain it somewhere. And how big is the drainage? Because the capacity is very huge because if you have like an LPG vessel, what you see, it will form some liquid LPG on the ground, and if you do not move them away, then when it's ignite, you will have a fire underneath the tank, and that is the most dangerous situation that we try to avoid because if you have a fire right at the bottom of the tank, the tank will take in the heat, and then because LPG is volatile, so it will evaporate inside and it will cause an internal pressure increase and explosion. So this is a situation we call very boiling liquid expansion and explosion. So this is a situation we try to avoid. Hence, if we have it above ground, we have to make sure when it's neat, it's blow away quickly so that it's going to different points. Then if that point, if there is an ignition there, and if it's ignite, at least they remain in the point and not directly impinge or impact the fire. It's not impact directly on the vessel. So I told them that yeah, we can put above ground, but you need to give me this space for that small impounding to collect liquid spill, and that has to be away from pipe rack because we don't want to damage fire to damage the pipe rack. So this is my requirement. And then when we put it above ground, we have more surface to that will require fire water to spray on when there is a fire to the surface down. So of course the fire water demand is big. If you put it underground, you only need to spray the front part that is exposed to the air. So this is the difference. So we do this costing of the shape in design, and then at the end the project actually agrees that the cost of changing in this design and increasing the risk does not make sense to be executed, and hence they keep it as underground. But that would mean that they have to pay more attention on the construction side and site preparation and have other mitigation means. Yeah. Last one. Last example is fire water requirement. So this one actually happened in one real life project that we need a fee, and then we want the fee. So we moved into detail design. So when we were in the fee stage, we say that for certain tank configuration, we use like a spray density of 2 liters per minute per meter square of the surface. Then we do all the calculation, we size fire water tank and the total fire water demand and everything. So we already enter a bit with that sizing basis and with some margin, but with that basis. Then at the end of the client brought our design package to the authority for fire protection review. And then the authority say that for this particular tank or systems, the density has to be 4 liters per minute, not 2. So obviously we are underestimate the design by half of the requirement. And we try to understand if it is possible to use this number or not, but the authorities say we have to follow the 4 liters per minute requirement. So this one is like one of our big lesson learned, because when we were in feed, clients inform us that we have to follow the adjacent plant design because this facility is building next to their old facilities. So they say the basis of the previous project, you have to use the same. So we follow that, so we use the same. But that project did not have to go through this authority gate review because the legal requirement was not online at that time. But our project has. So in this case, we faced with this problem. And then at the end, we have to change the design, which means it's a cost impact on our system like piping and sizing of our water system that we have to follow. But previously, the number that we use to liters per minute is also not wrong because it's also complied with the IT code, which is a European base. But the authority prefer us to follow the American based code. So with this kind of thing, if we know it upfront that the authority prefer American based code, then we would have size and price for everything since we and not have to keep our own budget in detail engineering design phase and have to retrofitting it according to the authority requirements. So yeah, so this is the one of the big lesson learned that when you establish the context, you need to know all the requirements, and at that time we did not know about this authority review process and requirements in it at all. So yeah, so this is the learning, and that brings me to the end of the presentation. Yeah. So any questions? Or any different experience that anyone wants to share with the class, because I think we all come from slightly different backgrounds and then the way we manage or see things will be different and in different industries. Yeah.
That's what I wanted to say, like, thank you for making it more simpler, because in our course we don't have two courses, but that course is related to occupational health and safety. This presentation was more related to the process safety, because your background is being a chemical engineer.
Yeah.
So thank you for making it more simpler to understand this one. And we do have another applied course, applied project management in petrochemical. So this presentation seems to be the integration of both of the courses.
Okay. Well, you know, thank you.
That's really nice. And I have one question. During the field design, I mean, you discussed everything about the process safety, about the plant and equipment. Do you consider the human to machine integration or human ergonomics while design?
Yeah. This one is one of the issue I have seen is that in many projects, especially in field, most of the time people ignore human factor or ergonomics design in field, and then when you come to EPC, usually client will require that. So if you have not do some like human factor screening in field phase or identify some potential big issues, for example, like for human factor part, one of the big tasks for them is related to the control. So the sizing, and how you design the screen and the integration between person and the screen. So all these requirements, if it's not properly done in field, or at least has some reserve budget for it, for potential issues, it could become a problem. But depends, like from my experience, because actually I have only worked for 2 years in engineering design companies, and previously I only worked in operation. So in my 2 years I have been in 2 seats and 1 EPC ongoing currently. So what I have seen is like 1 seat is not good and 1 seat has done. So yeah, so it actually whether we're gonna do it or not, it's not our call, it's our client's call. So because clients, when in field projects, they come with a list of studies and deliverables that they require. And usually if it is not in that list of deliverables, you going into project management and say, I need to spend 100 man hours, which costs this much, to perform this task and to identify something. Yeah, it is possible, but you need to have a good justification for that. Yeah, and it depends on the understanding of the project as well, whether they would allow you to spend the money and the impact if you do or without doing it. Yeah. But usually in field phase, usually at least in some project that has done, it's not detailed. It's only like a screening to understand, like for example, in a refinery, what are the health issues, what are the like kind of like a measure, like if you have the truck loading operation, this is a high like human involvement and it's high risk as well because you are loading like an flammable liquid or LPG. So for those things, we at least we identify what are the critical areas that that will require further detailed development studies, and we at least we know like okay, if unloading has an issue, how we gonna bring in the truck and all this. So at least we can talk to plot plan team and make sure that can give us enough like the bending and circles for the truck traffic and all this. So it's high level screening, but it's still at least enough for you to pick up big issues, at least to allocate the space. Because normally plot plan once it is frozen, it is very difficult to ask them to change or to allocate different things in different locations. Yeah. So in field, sometimes we do, sometimes we don't.
It's really important because machines we can control, we have automation,
Yeah.
control rooms and everything.
Yeah.
Human behavior we cannot control, so it's
Yeah.
quite unpredictable. So we have to work on that one because most of the incidents they arise from the human error.
Yeah.
And the machine is not integrated with the workforce. They are not compatible.
Yeah, I mean part of the ergonomics design is usually come from like a safety specification, like what are the height of a valve, if it's manual, if it's vertical. I mean there are like different requirements. What are the allowable space for personnel to walk around equipment? All these requirements usually state in. But at the same time, even though like we have these requirements, but we also have to talk to other disciplines because our requirements will be into piping design, will be into structure because they have to do the platforms, the ladders, and so on. So yeah, this one, if we miss, it could become like a potential issue.
Any other questions? During your work, you also have integration and you need communication with other disciplines.
Yeah.
What are the difficulty or maybe the risk in communication?
Usually at the beginning of the process, each discipline has their own specification. Yeah. So normally the design requirements are stated in those specifications. So normally those specifications, before going to client for review, we have an internal multidiscipline review process. So when it's sent to you, you have to read and you have to comment on them. So you have to read that spec basically and see that your requirements in that spec, whether they are missing something of your requirements. For example, like a question on ergonomics, civil heat, because most of you are civil, so I'm very busy calling civil. Civil is responsible for constructing the steel platform and stairs and ladders. So they have their own specification to say how wide and what are the angles. But our human factor also has the different requirements. So in this case, for example, like if client has to, normally we have to consider like the platform width to be able for some people to carry a stretcher if there is an incident and they need to bring the stretcher to put the person in and transport them, it should be allowed. And then we find out the problem that there is a clash in specification because civil has, when we bring them down to the stair and make a U-turn, this landing platform is not enough, it's too small. So there are some kind of like a slightly conflict in requirements, and this kind of thing, if you know it upfront early in the project, if you read someone else's specification, we can have a discussion and early decision from the project how to treat them because many times actually it's my learning as well that many times when I'm working in engineering side company safety cannot overrule everything unless it is clearly does not meet the code and standard. But if something like a nice to have or general practice, sometimes if you find this out at the middle phase of the project, it's a bit more impact to the design and it will involve more people to make a decision. Yeah, and sometimes you can change and sometimes you may not be able to change it to the level that you want. You may be able to change it just slightly. So yeah, so this is one of the way that we do the discipline review of specification. So for your spec, you have to make sure that everyone else, other teams read it and comment. This is the part because I need to make sure they understand my requirements upfront. And then because they know if I ask something too much, it's already a conflict. Like for example, clients want us to use one type of cable with different test methods for 5 resistance. And the instrument team is using different specs. They follow IEC. Client asks for UL, which is the American one. So in this case, if you ask safety, of course UL is better because the duration and the integrity is safer. But IEC is already good enough as well. So there are some kind of conflict like this all the time with all the discipline, big and small. So you have to spot that out quickly, and if it's a problem, it's like a multidisciplinary decision to look at them together and then talk to clients. Yeah. So manage other discipline as well as manage client is equally important. I mean, client is a bit more difficult because of course you as a client you design a facility that for them is like 30 years or kind of like a lifetime facilities for them. So for them, they want it to be the best, but then sometimes due to like a project schedule, if you accommodate, if they tell that they want something quite late in a project, and then if you try to accommodate their requirement, it could jeopardize other disciplines. Yeah. So from safety point of view, it's quite a challenge position because when most of the time when they want to save something, they will say this is not safe, and then everyone will come and this is not safe, and what do you think? And so it's sometimes it's quite difficult to manage. Yeah. But as a professional, we because there are a lot of like reference like industrial experience, like industry accidents, code and standards and many things, onshore and offshore. So we have a lot of database to explain to why we are doing this or why we don't think this is necessary for certain things that they request. Or if at the same time, if we really insist that some things need to be changed, then we also use those information to help internally. Because apart from convincing other disciplines, it's the project management call whether they will allow such a change or not if it's a big impact.
Continue this continuation, like since you have worked with operations also, how was your experience? Because there's always a tussle between safety and the production. Clients sometimes he focuses more that you need to improve the production, you need to increase the production. Sometimes you have to compromise safety also. So how was your experience?
Because my background, because I work for Tour, Chevron, he always teach me to put safety as a first priority. So when I work there, when we see something unsafe and make a recommendation, usually when I blow the whistle, everyone hears it. But when it's come to sitting at engineering design office, most of the time, sometimes clients does not have like a strong understanding of safety. So they indeed they are more focusing on productivity to make sure it's reliable and continuously running because each day that the production stop is meaning the loss in their money. So sometimes I experienced this once in my first field project that they did not really focus on safety and I had to step up and just tell them that okay this is what you want but this is not safe. At the end it is your call, it is your people but from our experience we think it's like that. It's your decision. Do you really want us to decide like that? Yeah, so we can have an open communication to talk to them for such a case.
Another thing that I need to know is what kind of simulation software will you use during these CB&I?
If you are talking about safety, because we are responsible for firefighting design, like fire water design, so we use like pipe net.
Right.
Yeah, like to calculate the velocity, like the flow of water inside the pipe and all this. When we do the consequence modeling, we call like the QRA. That one depends on clients. They sometimes they have like a specific requirement, like you have to use fast software for consequence modeling. Sometimes they do not specify, so it depends on them. And sometimes in some projects, we usually use fast for a quick QRA, but if you work for like an offshore project, then they will say we need a CFD simulation to simulate the risk in CFD. So yeah, so it really depends on what they ask. And we use a software called like a waste file to simulate what is the failure time if you have a file imposing on equipment like vessels and how fast it will lose the integrity and leak and burst and all. So yeah, so we are more using these softwares and also the noise. There are a lot of like noise mapping software, so that is one of the tools. And on the process safety side, we use like PHA for HACCP workshop and excellence here for seal assessment.
Questions? No, like you have experience in developing countries and developed countries. So from your experience, do you think there is different perspective of safety from the client in developing country and developed country, or maybe the regulations in developing country and developed countries for safety?
Actually, I think it of course whether it's developing or developed, that may not be as different in terms of requirements. I mean, with respect to requirements, it's more on the regulation of each local countries. So for example, like in Thailand, the requirement in fire safety is not as strict as in Oman, for example. So this is like the legal part, but then for the other part, which is the company themselves, that is more like if you are working for Shell, whether it's in Thailand or Shell in there, it's the same product standard and level of expectation. So the company one really depends on each company. Yeah. But if you are looking at like human behavior, this part actually there is slightly different role because like for example what I experienced is like in different plants, like when I look at the firefighting design, sometimes they will say that if there is a fire, I will send people inside the fire. Whereas more different company will also say that if there is a fire, we will shut down, we put everything in automation, we run. So it's kind of like a different, strategy and fighting. But I think that is also due to the nature of people and how well trained there are with respect to the facilities that is involved. Yeah. And then the ergonomic side, this one is slightly different because of the different posture and height. So sometimes it is a problem that when you use like the big companies code and standards, usually it's based on European. So all the ladder cage and everything is quite big compared to Asia where we have slightly smaller bodies. Yeah. So and it's a bit difficult to go and ask for the global authority to say that we will use a smaller cage. Yeah. So this kind of thing has been known, but most of the companies they insist that we want to use a general number, so the sizing and everything we want it to be standardized. So if you stand in one plant in Thailand and one plant in US, this standardization is the same. So they usually say you just follow, but then the operator has to be a bit more careful. Yeah.
So in oil and gas here, usually the cost for safety here is how many percent of the production?
Actually, it's a bit difficult to say because actually I only know that usually the split between engineering and the rest is only like 10%. So cost-wise, 10%. So this 10%, all your choices of the design will impact the rest of the 90%, but which is in construction and all that, but yeah, and actual processing. So basically, this put us back to the emphasize that your design choice, not too much, not too less, is very important to balance the risk, but at the same time, not over design for something that will not be used. Yeah. Because as a safety, we got this kind of quite a challenge because clients always ask a lot of things, and then sometimes what they ask cannot be fully implemented because it's beyond normal industrial practice, and it will increase a lot of project costs. So we have to negotiate and say that what you are requesting, we understand your concern from this thing. Like if there is a fire, then they ask us to fireproof everything, and we cannot fireproof everything. Of course, because fireproof is actually not only cost, but when you put fireproof on, you increase and a corrosion risk underneath the fireproofing. So we try to only put fireproof in the area that is really important to make sure the structure stands still under the fire and not collapse and all this. So we have to like prioritize and only select like the real element that is really needed. So it's kind of risk-based, yeah. And then yeah, it's put us back to clients and then try to explain that we cannot give you fireproof, but another system that is usually used to fighting the fire is this, and we will ensure that there will be enough enough firefighting water reaching this area if you have a specific concern and so on. So we have to like negotiate.
Questions?
I hope the talk at least give you like some kind of basic understandings in case if you have to go and work in oil and gas industry, yeah, on the way they look at safety, because yeah, for oil and gas it's hydrocarbon, and obviously it's like a risk to everyone. So this area of safety is quite specific, yeah. And still need a lot of understanding and attention from other people, but we are getting there somehow. Yeah. So.
Can we get your contact details because we need to ask something maybe later on?
Oh yeah. you can send an email to my email address, so tpitikon@gmail.com. Yeah, that way it's easier to reach me because if you send it to my company's email, normally it will treat external mail to junk, and yeah, sometimes I may miss it. Yeah. So if you have any questions on this, yeah, feel free to contact me. Yeah, and I'm happy to share information. And thank you very much for your attendance and your patience. Yeah, and it's actually my first time to present and to talk about this topic as well. Yeah, so yeah, thank you. Yeah.
So we are grateful here for her to spend her time with us, giving the presentation from her experience. So you learn already project management, you learn department management, you know how important the holistic point of view here. So you should not only equip yourself with only project management, you need like economic, you need to know about culture. So one part is she already explained to all of us here. So thank you very much. I hope we can enjoy your presentation for the other occasion. Please give a thank you.